determine the ambient temperature near a hot metal halide bulb, you can use the following formula: T equals Th minus the quantity Th minus Tc divided by the quantity R times D. In this formula, T represents the ambient temperature, which is what you want to find. Th represents the hot temperature, which is the temperature of the heat source. In this case, it would be the base of the halide bulb. Tc represents the cold temperature, which is the room temperature or the temperature of the surroundings. R represents the thermal resistance, which is a measure of how well the material resists heat flow. In this case, is the resistance of the reflector plate. Finally, D represents the thickness of the material, which is the thickness of the reflector plate. It is important to note that this formula is an approximation and may not be accurate in all cases, but it can give you a reasonable estimate. Considering the situation with the metal halide bulb, where the wiring is showing signs of heat damage due to its proximity to the reflector plate, there are a few options to consider. Firstly, an insulation shield could be placed behind the reflector plate to reduce the heat transfer from the bulb to the wiring. If you choose this option, it is crucial to select an insulation material that is rated for high temperatures and is non-flammable to prevent any fire hazards. Secondly, rerouting the wire away from the bulb reflector is the safest option, as it will eliminate the risk of heat damage to the wiring. This may require some additional work, but it is the most reliable solution to ensure the long-term safety and reliability of the electrical system. There are other considerations to keep in mind as well. 1. Ensure that the bulb is properly ventilated to prevent overheating. Proper ventilation will help dissipate heat and keep the bulb and surrounding components within safe operating temperatures. 2. Regularly inspect the wiring for signs of heat damage. This will allow you to identify any potential problems early on and take corrective action before they lead to more serious issues. 3. Use high temperature wire that is rated for the specific application. High temperature wire is designed to withstand the heat generated by the bulb and will provide a more reliable and safe connection. Regarding specific insulation materials, some options include fiberglass insulation, ceramic fiber blankets, and high temperature mineral wool. These materials are designed to withstand high temperatures and provide effective thermal insulation. When choosing an insulation material, it is essential to consider its temperature rating, flammability, and thermal conductivity. Look for materials that are specifically designed for high temperature applications and have a low thermal conductivity to minimize heat transfer. If rerouting the wire, ensure that the new routing path complies with all applicable electrical codes and regulations. The National Electrical Code, or NEC, provides guidelines for proper wiring practices, including clearances from heat sources. Consult the NEC and local electrical codes to ensure that the rerouted wire is installed safely and correctly. When inspecting the wiring for heat damage, look for signs such as discoloration, cracking, or melting of the insulation. If you find any of these signs, the wiring should be replaced immediately by a qualified electrician. It is also a good idea to check the wire connections to ensure that they are tight and secure. Loose connections can cause heat buildup and increase the risk of fire. The type of high temperature wire to use will depend on the specific application and the temperature rating of the bulb. Some common types of high temperature wire include Teflon insulated wire, silicone insulated wire, and fiberglass insulated wire. Choose a wire that is rated for the maximum temperature that the wiring is likely to be exposed to. It is also important to consider the wire gauge, which should be appropriate for the ampacity of the circuit. The National Electrical Code Table 310.15b16 provides guidance on wire ampacity based on wire size and insulation type. Another consideration is the type of metal halide bulb being used. There are different types of metal halide bulbs, each with its own operating characteristics and temperature ratings. Consult the bulb manufacturer's specifications to determine the maximum operating temperature of the bulb and ensure that all wiring and insulation materials are rated for that temperature. It is also important to consider the ballast used with the metal halide bulb. The ballast is a device that regulates the current to the bulb and can also generate heat. Ensure that the ballast is properly ventilated and is not located in close proximity to the wiring. Some ballasts are designed to be mounted remotely, which can help reduce the heat load in the wiring. In addition to the above considerations, it is also important to ensure that the lighting fixture itself is properly designed and constructed. The fixture should be made of materials that are resistant to heat and corrosion and should have adequate ventilation to dissipate heat. The fixture should also be properly grounded to prevent electrical shock hazards. Grounding is an important safety measure that helps to protect people from electrical shock in the event of a fault. The National Electrical Code Article 250 provides detailed requirements for grounding electrical systems and equipment. Another aspect to consider is the ambient temperature of the environment in which the lighting fixture is installed. If the ambient temperature is high, it can further increase the temperature of the bulb and wiring. In such cases, it may be necessary to take additional measures to reduce the heat load, such as using a larger fixture or providing additional ventilation. The location of the lighting fixture can also affect its temperature. If the fixture is installed in a confined space, such as a small room or closet, the heat can build up quickly. In such cases, it may be necessary to relocate the fixture to a more open area or to provide additional ventilation. Regular maintenance is essential to ensure the safe and reliable operation of metal halide lighting systems. This includes cleaning the bulb and fixture regularly to remove dust and debris, inspecting the wiring and connections for damage, and replacing any worn or damaged components. It is also a good idea to periodically check the voltage and current to the bulb to ensure that it is operating within its specified parameters. If you are not comfortable working with electrical systems, it is always best to consult with a qualified electrician. The electricians have the training and experience to safely and effectively install and maintain lighting systems and can help ensure that your system is code compliant and operating safely. They can also help you troubleshoot any problems that may arise and recommend appropriate solutions. When working with electrical systems, it is important to always follow safe work practices. This includes disconnecting the power before working on any wiring or components, using appropriate personal protective equipment such as gloves and eye protection, and following all applicable electrical codes and regulations. Remember that electricity can be dangerous, and it is important to take all necessary precautions to prevent accidents. In summary, calculating the ambient temperature near a hot metal halide bulb involves using a specific formula that takes into account the temperature of the heat source, the room temperature, the thermal resistance of the reflector plate, and the thickness of the reflector plate. Addressing the issue of wiring near a hot bulb involves considering insulation shields and rerouting the wire. Prioritize safety by ensuring proper ventilation, regular inspections, and the use of high-temperature wire. Always consult with a qualified electrician if you are not comfortable working with electrical systems. Metal halide bulbs are known for their high efficiency and long lifespan, but they also generate a significant amount of heat. This heat can be a concern, especially in enclosed spaces or when the bulb is located near combustible materials. Therefore, it is important to take steps to manage the heat and prevent any potential hazards. One way to reduce the heat load is to use a low wattage bulb. If the lighting application does not require a high level of illumination, a lower wattage bulb can be used to reduce the amount of heat generated. Another option is to use a different type of lighting technology, such as LED lighting. LED lights are much more energy efficient than metal halide bulbs and generate significantly less heat. They also have a longer lifespan and require less maintenance. However, LED lights may not be suitable for all applications, as they can be more expensive than metal halide bulbs and may not provide the same level of illumination. When installing metal halide lighting fixtures, it is important to consider the mounting location. The fixture should be mounted in a location that allows for adequate ventilation and is not near any combustible materials. It is also important to ensure that the fixture is properly grounded to prevent electrical shock hazards. Grounding is an important safety measure that helps to protect people from electrical shock in the event of a fault. The National Electrical Code Article 250 provides detailed requirements for grounding electrical systems and equipment. Another consideration is the type of enclosure used for the lighting fixture. The enclosure should be made of materials that are resistant to heat and corrosion and should have adequate ventilation to dissipate heat. The enclosure should also be properly sealed to prevent the ingress of moisture and dust, which can damage the bulb and other components. Regular cleaning of the lighting fixture is essential to maintain its performance and prevent overheating. Dust and debris can accumulate in the bulb and reflector, reducing their efficiency and increasing the amount of heat generated. The fixture should be cleaned regularly using a soft cloth and a mild detergent. Avoid using harsh chemicals or abrasive cleaners, as these can damage the bulb and reflector. When replacing a metal halide bulb, it is important to use the correct type and wattage. Using the wrong type of bulb can damage the fixture and create a safety hazard. Always consult the fixture manufacturer specifications to determine the correct type of bulb to use. It is also important to handle metal halide bulbs with care. The bulbs contain mercury, which is a hazardous substance. If a bulb breaks, avoid touching the mercury and ventilate the area. Dispose of the broken bulb properly in accordance with local regulations. In addition to the above considerations, it is also important to be aware of the potential health effects of metal halide lighting. Metal halide bulbs emit ultraviolet, or UV, radiation, which can be harmful to the skin and eyes. Prolonged exposure to UV radiation can increase the risk of skin cancer and cataracts. To protect yourself from UV radiation, wear protective clothing and sunglasses when working near metal halide lights. It is also a good idea to limit the amount of time you spend in the vicinity of metal halide light. Metal halide lighting systems are widely used in a variety of applications, including street lighting, parking lots, sports stadiums, and industrial facilities. They offer a high level of illumination and are relatively energy efficient. However, they also require careful planning, installation, and maintenance to ensure their safe and reliable operation. By following the guidelines outlined above, you can minimize the risks associated with metal halide lighting and ensure that your system operates safely and efficiently. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is updated every 3 years and provides detailed requirements for the safe installation and operation of electrical systems. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is an essential resource for electricians, contractors, and anyone else who works with electrical systems. When working with metal halide lighting systems, it is important to comply with all applicable requirements of the NEC. This includes ensuring that the wiring is properly sized, that the overcurrent protection is adequate, and that the equipment is properly grounded. Failure to comply with the NEC can result in serious safety hazards and can also void your insurance coverage. The NEC is available for purchase from the National Fire Protection Association, or NFPA, and is also available online. It is a valuable resource for anyone who wants to learn more about electrical safety. In addition to the NEC, there are also a number of other standards and guidelines that are relevant to metal halide lighting systems. These include standards from the American National Standards Institute, or ANSI, and standards from the Illuminating Engineering Society, or WISE. These standards provide guidance on the design, installation, and performance of lighting systems. They can be helpful in ensuring that your lighting system meets your specific needs and requirements. When planning a metal halide lighting system, it is important to consider the overall lighting design. The lighting design should take into account the specific tasks that will be performed in the area, the desired level of illumination, and the energy efficiency of the system. A well-designed lighting system can improve productivity, enhance safety, and reduce energy costs. There are a number of software tools available that can help you design a lighting system. These tools can simulate the lighting performance of different fixtures and layouts and can help you optimize your design for energy efficiency and performance. It is also a good idea to consult with a lighting designer or engineer. These professionals have the expertise to help you design a lighting system that meets your specific needs and requirements. They can also help you comply with all applicable codes and standards. In conclusion, Metal halide lighting systems offer a number of advantages, including high efficiency and long lifespan. However, they also generate a significant amount of heat and require careful planning, installation, and maintenance. By following the guidelines outlined above and complying with all applicable codes and standards, you can minimize the risks associated with metal halide lighting and ensure that your system operates safely and efficiently. The formula for calculating ambient temperature is a useful tool for understanding the thermal environment around a metal halide bulb. However, it is important to remember that this formula is an approximation and may not be accurate in all cases. The actual ambient temperature can be affected by a number of factors, including the airflow around the bulb, the presence of other heat sources, and the reflectivity of the surrounding surfaces. Therefore, it is important to use the formula as a guide and to supplement it with other measurements and observations. For example, you can use a thermometer to measure the ambient temperature at different locations around the bulb. You can also use a thermal imaging camera to visualize the heat distribution around the bulb. These measurements can help you identify any hot spots and take steps to mitigate them. When choosing an insulation material for use behind the reflector plate, it is important to consider its thermal conductivity, its temperature rating, and its flammability. The thermal conductivity is a measure of how well the material conducts heat. A lower thermal conductivity means that the material will be more effective at insulating against heat transfer. The temperature rating is the maximum temperature that the material can withstand without degrading. It is important to choose a material that is rated for the maximum temperature that it is likely to be exposed to. The flammability is a measure of how easily the material will ignite and burn. It is important to choose a material that is non-flammable or that has a low flammability rating. There are a number of different insulation materials available that are suitable for use behind the reflector plate. These include fiberglass insulation, mineral wool insulation, and ceramic fiber insulation. Each of these materials has its own advantages and disadvantages. Fiberglass insulation is relatively inexpensive and has a good thermal conductivity. However, it can be irritating to the skin and lungs. Mineral wool insulation is also relatively inexpensive and has a good thermal conductivity. It is also less irritating than fiberglass insulation. Ceramic fiber insulation has a very low thermal conductivity and can withstand very high temperatures. However, it is more expensive than fiberglass insulation and mineral wool insulation. When rerouting the wire away from the bulb reflector, it is important to ensure that the wire is properly supported and protected. The wire should be run in a conduit or cable tray to protect it from physical damage. The wire should also be supported at regular intervals to prevent it from sagging or straining. The wire should be routed away from any sharp edges or other potential hazards. It is also important to ensure that the wire is properly connected to the electrical system. The wire should be connected to a properly sized circuit breaker or fuse. The wire should also be grounded to prevent electrical shock hazards. Grounding is an important safety measure that helps to protect people from electrical shock in the event of a fault. The National Electrical Code Article 250 provides detailed requirements for grounding electrical systems and equipment. When working with electrical systems, it is important to always follow safe work practices. This includes disconnecting the power before working on any wiring or components, using appropriate personal protective equipment such as gloves and eye protection, and following all applicable electrical codes and regulations. Remember that electricity can be dangerous, and it is important to take all necessary precautions to prevent accidents.